We're going to continue factoring trinomials of the form x squared plus bx plus c in this video. On the last video, the very last problem that we worked on, we kind of started moving into this type of problem where there's a little bit more to do with positives and negatives. It's a little less straightforward from the first ones that we were working on. The process is exactly the same. When we solve these, we are going to list factors of, in this case, it'll be -7. And I can rewrite this as x squared plus 6x plus -7 to make that apparent that it is factors of -7 that add up to the coefficient here is 6. So factors of -7 that add up to 6. And so we just start listing factors of -7. -7 and 1, that adds up to -6. That is not meeting our requirements. 7 and -1, that adds up to 6. That is going to work. So we are going to replace this 6x with 7x plus -1x. So we'll do that now. X squared plus 7x plus -x plus -7. And then I did not show this last video. It is a strategy that can help if need be. And it will help when we start having coefficients here other than 1. You're going to want to use this little Punnett square, this right here. And the way we're going to use it is we are going to put these terms, these are in order x squared, x, and then just a constant. And we're going to put them in our Punnett square. So we have x squared, 7x, -x, and -7. And then what we put on the outside here and here and here and here, those are going to make up our binomials that we multiply to get these 4 terms here. So for instance, this times this is going to get this. This times this is going to give us this. This times this will give us this one. And this times this will give us this. So for the first one, x times x is going to give us x squared. And then x times 7 would give us 7x. So this is going to be 7 right there. And then x times what would give us -x? Well, that's got to be a -1, so we'll put -1. And so this is one binomial, x plus 7, and this is our other binomial, x minus 1. X plus 7, x minus 1. And so that's one. Using the Punnett square is helpful. When you have a coefficient of 1, really you can just use the coefficients because they're the same down there, like we did in the first video. But this is a really nice tool to help with finding out your binomials that you multiply to get these 4 terms. I'll keep using this here so we get some practice with it. Let's do another example. All right, here's another example. We got y squared minus 3y minus 54. If you want to, you can go through, rewrite as an addition statement. It might help to identify what your signs are on your terms. So I am going to be creating a table that is factors of -54 that add up to -3. So we'll do that here. Factors of -54. And those factors have to add up to -3. All right, so factors of 54. The first one that pops in my head is 2 and -27. That's definitely not going to work. The sum there is -25, so that's a big nay. You can always check the other way. If you had -2 and +27, that would just be 25, so that's also a no. Other factors of 54, 3, -18. That's going to give us, -15, not what we're looking for. That's +15, that's a big nay. It's also what a horse says. And let's see, how about negative 9 and 6? So 9 times 6 is 54, negative 9 times 6 is negative 54. And add those up, we get negative 3. That works. So we're going to replace our middle term here, negative 3y, with negative 9y and 6y. So y squared plus negative 9y plus 6y plus negative 54. And I am going to put that into our box here. So we've got y squared, negative 9y, 6y, and negative 54. So this will be y times y. And then y times what will give me 6y? Well, that's going to be 6. So this is 6. And then y times what would give me negative 9y? That's going to be negative 9. And then we can check it and just say, okay, 6 times negative 9, that's negative 54, so that works. So our factors are y minus 9 times y plus 6. Just like that. Okay? We can do some more examples in class tomorrow. The process is basically the same over and over again for these. This is a little bit new here, working with the box or the Punnett square, whatever you want to call it. And so we'll continue to use that. Bring in questions if you have them.